Hello guys, welcome to Sumo Code. So today we are going to learn about what vector databases are, why are they used, when are they used, and how are they used. And also we will look at the use cases which are making them so famous nowadays. So let's start into it. So if you would look at the current situation of the internet, most of the data that is present over there is unstructured. By unstructured, what I mean to say is most of the data is like image, text, audio, or video. Videos are just a series of images. So most of the data is unstructured. And if you have a use case which is very common in the current world, like find similar images to this, find similar videos to this, or find answer to this query of mine. So if we want to perform those operations and if we are storing our unstructured data in our traditional database like a relational or a document DB or a graph base, so it becomes very hard to support these kinds of operations if we are storing our unstructured data in a traditional database. Let me explain you how it becomes so much difficult. So consider this example where we want to find similar images. So for this, consider if this is the image, and if first of all we would be storing our image on over our traditional database. And consider I have a MySQL database, and how I would try to store this to support this functionality. So if this is the image that I want to store, then I would try to create tags for this, like what is the color of the cat, what is the eyes color, what is cat doing, what is the size of the cat, and what is the this image representing. So we have to create all these tags, and creating these tags can be cumbersome. Like it would get very hard for you to create these tags, and you have to perform some OCR operations or image recognition. So all these things you have to perform to just store this image into this table, and then also you have to then perform searches over this. So it becomes very much cumbersome, and it's becomes very hard to support this use case. So what is the other way you can do it? So the other way is to use vectors. The cool thing about vectors is you can represent anything using a vector, like a text, an image, an audio. So anything you can represent using a vector. And what is a vector? Vector is just a list of numbers representing something in a multidimensional space. So this array here you can see, this is a vector which represents something in a multidimensional space. Now, another cool thing about vector is that these are just a list of numbers. It does not tell you anything about what it is representing, how it was created. So nothing it tells you about. It's just a list of numbers. So how are the vectors used then? So they help us by creating an embedding. So what are embeddings? Embeddings are also a vectors which are specifically designed to capture some semantic meaning of a text, image, or audio. And how are these embeddings or vectors, special vectors created? They are created by passing your text, image, or any data to embedding model. So if you would pass any data to embedding model, you would get embeddings, and embeddings are nothing but special type of vectors only. So what I have just said is any data we can represent it as vector, and vector is also a special type of embedding. So all these are nothing but same which we can represent. So now how these embeddings are special, like how they capture semantic meaning and how they would support our use case. So what happens is that when you create an vector using an embedding models, what happens is that similar type of data of which you are creating an embedding or a vector of are made closer to each other, or are stored in a multidimensional space closer to each other. So what I am trying to say is, if I have a data, so this is my data, and if I pass it through embedding model, then if similar image or similar data is there, they would be pointed closer to each other in this multidimensional space. And if something dissimilar type of data I'm passing to this embedding model, they would be stored away from each other. So now when you would try to find similar images or similar text, something that type of query, then what it would do is it would find the vectors which are nearer to each other, and those would be the answer to your query. And these vectors which are not close to the original vector which we are trying to find, they will not be outputted in the query, and they are dissimilar. So that's how embedding models help us in creating embeddings, which will help us solve the use case of finding similar images or doing semantic search over our data. So now what is an embedding model? You would want to know how are they created. So embedding models are made by training a neural network to map any text or any kind of data in a vector space such that similar data is mapped closer to each other. Just what I explained earlier. So these are just neural networks which are made to map your data to a vector. So that's what they do. And while doing this, they make sure that similar kind of data is stored closer to each other. So the examples of embedding models are BERT is there. Then there is this very famous one, OpenAI's text embedding, ADA 002. And there are some special kind of embedding models as well, which would support some special use cases like medical is there, or some law kind of embedding models are there, which would help in use cases when you are having a use case where, consider, you only have medical data which you want to find similarities of. So those models are more capable of finding similar searches over those kinds of data. And all these embedding models are open source mainly. This one is not. So open source, and you can find this over Hugging Face or any other platform online. So this is all about embedding models and vectors which would help you find similar searches. Now I have covered everything about how this would be supported. Now the main topic of this video was what are vector databases. So what vector databases are? Vector database stores these vector embeddings and indexes them to do faster retrieval and similarity search. So what we were trying to achieve earlier, all these things like creating vectors of data or embeddings and doing similarity search, all these can be coupled together in this vector database, and vector database would give you out of the box these functionalities. So what vector database do is like they stores your data. So how they would store is, so if consider if you want to insert some data and it is a text, it will go to an embedding model that you would specify what kind of embedding model you want to use. It will create that embedding, store them, and also it would index them as well, because you want faster retrieval as well. For that, these vectors would be indexed as well. Now whenever a search would come, it will be again passed to your embedding model. Its similar embeddings would be made, and it would be searched over this vector database. And because this is index data, the retrieval or the searching would be faster. And whatever the whatever the points or the vectors which would be found closer to this embedded search query vector would be returned. So nearest distance vectors would be retrieved. So here again, as you can see, what I made in a vector database, whatever data that you are storing, they would be stored as vector embeddings and they would be indexed just for the faster retrieval. So now there are few vector database which are coming up and very much hot in the market. Like everyone wants to use them. Some of them are like weaviate, pinecone. They have raised a lot of funding as well. So what they provide is a quick way, means APIs and libraries they provide you to quickly store your data in the form of embeddings and then perform quick retrieval on them. You can also provide some custom embedding model as well, which you are hosting it at your own server. So you can also specify that so they can use those as well. So in short, vector database helps you to fix the use case of finding similar such as similar type of things using the power of embeddings or the vectors. So some of the use cases which are very much favorable towards using a vector database. So one of them is the RAG, which will allow you to give a long-term memory to your LLMs. Like because LLMs have a limit on how much tokens that you can send in a request. So using a vector database, you can perform like you can store your data in a vector database, and based on your query, so some query would come, it would search on your vector database and retrieve your documents which are related to that query, and then using these data and the query, that data would be passed to your LLM. So it will give you a long-term memory kind of solution. So other use cases like doing a similar search, recommendation system. So all these are use cases which are used very much widely in the current world. So that is what making vector databases very much famous nowadays. So this is all about vector database. Hope you understand what vector database is, how are they used, what makes them very much special. I would also be making a video about how to use a vector database, all the code, everything about around that. So I would be making that. So if you have any doubts, please write it down in the comments below. I will try to answer them as quickly as possible. Please leave a like if you like the video. Any feedback that you have, please write that down in the comments again and subscribe to my channel. So thank you. Bye.